This is question 17 from Book 1 based on the 2020 NEC, and this is electricaltime.com. You are asked to install show window lighting circuits and have a max of 50 amps per leg to work with from the 120 volt / 240 volt single phase panel board. You have decided to install a sub panel in close proximity to the show window lighting to make it convenient for the maintenance personnel to turn those lights on and off. What is the max number of linear feet of show window lighting that can be supplied from the sub panel? And the answer to this question. Hi, this is Steve with electricaltime.com. Before we get back to our video, just want to show you our website real quick. It's called electricaltime.com, and we got some really cool things here. We've got online electrical classes, so go check them out. And also, we got free videos. So go back to our website each week and, check out our free videos. All right, now back to this video. Is going to be C, and that is going to be 48. Now let's see how we found the answer to this question. And the first question we're going to ask ourselves here is, what article are we talking about? And that's going to be Article 220, and that's branch circuit feeder and service load calculations. And that's going to be within Chapter 2, Wiring and Protection. And in Article 220, we find Part 2, which is called Branch Circuit Load Calculations. And then we find 220.14, Other Loads for All Occupancies. And then we find 220.14G for Show Windows. So we're going to go to step number 1. We have a max of a 50 amp sub panel, and we know that lighting is considered to be a continuous load because it will be on for 3 hours or more. When we have a continuous load, we normally take the max continuous amps and multiply it by 125% so we can size our conductors. In this case, we have to work backwards and start at 50 amps per leg and multiply that by the inverse of 125%, which is 80%. 50 amps per leg times 80% gives us 40 amps per leg to work with. All right, because we're starting with that sub panel and we're being told we only got 50 amps per leg to work with. Because we're starting there at the sub panel and we know that lighting is a continuous load, I'm going to have to use 80% of the 50 amps, and that's going to be 40 amps. And that's going to be 40 amps per leg that I can work with. All right, let's go to step number 2. So 220.14G tells us to use 200 VA per linear feet of show window lighting. We have 40 amps available to use on line 1, or leg A, which gives us a total of 4,800 VA, and we got that by 120 volts times the 40 amps, and again, that's 4,800 VA. We then take the 4,800 VA and we divide that by 200 VA for each foot of show window lighting, and we get a max of 24 feet per leg. And again, we took the 4,800 VA, divided that by the 200 VA, and then we got 24 feet. Okay, let's go on to step number 3. Since we have 2 legs on this 120/240 volt service, and each leg can accommodate 24 feet, therefore we can have a total of 48 feet of show window lighting on the feeder for the sub panel. And let's go to step number 4. Let's see what we got to say over here. So step number 4. So double check yourself by taking the total available VA of the sub panel, which now we can do this as 240 volts times 50 amps. So we got a total potential of 12,000 VA. Let's take 80% of the 12,000 VA and multiply it by 80% for the continuous load in amps, and we get 9,600 VA. Let's take the 9,600 VA and divide it by 200 VA for each foot of the show window lighting, and we get the same max number of feet, which is 48. And again, that's 9,600 VA divided by the 200 VA for the show window lighting, and that's going to give us 48 feet. And again, our answer is C, and that's going to be 48. And the reference here is the General Electrical Formulas and 220.14G.